lah sebab soalan ni saya dah pernah tanya dalam our previous apa tu previous learning activity. Mula you masuk dulu kod tadi tu berapa jawapan, apa jawapan untuk soalan ni. Okay, dah ada 2 orang join. So you can join this by entering the class code number 2015. Sebab saya bukan apa tau, saya dah tengok lah kan you punya involvement lah. So back to this question, the trial test performed on the sample under unconsolidated undrained conditions, which is maximum exit stress of 106 kPa when confining stress is 40 kPa. What is the value of cohesion under shear strength from this sample? Another sample set sinusoid is tested in unconfined compression test. There is no confining pressure is applied. What is it that is expected to cause failure? Okay, can you give me what is answer? Antara jawapan A, B, C. Okay, good. So I got answer. So daripada 4 yang join, kita ada jawapan 3 orang untuk jawab A dan yang kita ramai join kan. So just close to the submissions. Okay, this one will be continuously in activity untuk kita punya orang kata apa, just checking your understanding lah sebelum kita pergi topik yang seterusnya. Okay, what exactly stress pass? Wait a second, okay, I think that I forgot to. Okay, you have helped me. Record the. Okay, what is a stress pass? Stress pass is actually a form of representing the failure of the sample through the testing in a coordinate. For example, that dalam stress pass ni, apa yang membezakan stress pass dengan curve stress strain adalah ia menggambarkan satu laluan failure of the samples. So kalau you plot stress strain curve, you will have the stress strain. So contohnya kan, if you remember how do you plot the stress strain, whatever test, sama ada triaxial test ataupun finally kita akan dapat the strength of the soil antara C dan juga Phi. Before you can have this one antara tau dan juga dia punya sigma, yang you kena plot graph pertama, this one we call it as a here is this is the curve yang mana you akan ada displacement. For example, here you have the normal stress and here you have the normal strains. So this is the way when you plot kat sini kan, you akan nampak dia punya lengkung stress and strain. What makes difference between stress path dengan curve stress and strain? Okay, dalam stress path ni kan, kita akan represent the failure of the sample menggunakan maximum failure point dia. Contohnya kan, how do we have the small column failure envelope? Dengan cara you kena plot the curve circle between the sigma 3 effective, for example, if you have the effective strength parameter, and between the effective major stress. So remember, when you have the effective sigma 1, also called as a axial stress ataupun kita panggil dia principal major stress or effective sigma 1. Meanwhile, for effective sigma 3, we call it as a confining stress. At the same time, the sigma 1 is also known as a axial stress. So there are many abbreviations to represent the sigma 1 dan juga sigma 3. But this is the things where when you want to show the failure of the samples or you want to get the strength of the samples, first you need to get the stress strain curve and then you plot to the second graph between the shear stress and also the normal stress. So bila you plot kat sini, you akan dapat the strength parameters C dan juga Phi. the thing is that I try to explain here is the stress path. Di mana berlakunya stress path? Sebenarnya kita boleh dapat stress path you kena tahu dia punya locations of the failure point. Okay, yang ni yang graph saya buat ni not in scale lah. So kalau kata lengkung awak your punya lengkung curve ni this is the maximum one. So from your center of the circle you kena plot daripada center of circle sehinggalah maximum of the curve, that is your failure of the stress. So ini menggambarkan satu sampel. How about if you have many samples that represent to you different failure? Maknanya you ada sampel pertama color hitam, kemudian sampel kedua color merah, sampel ketiga dia akan bagi you different color. And you can see that all these failures from curve black, curve red and curve blue give you different maximum failure stress. Warna biru dia punya stress at this point. For example here, let's say saya namakan sample number C lah. And then for sample red, this is dia punya maximum point dia. So when we connect between the samples 1, 2, 3, at the maximum of the failure stress here, dia akan bagi you satu laluan yang kita panggil dia sebagai stress path. So the stress path can be presented in the coordinate T and S, or you can see in the P and Q. Okay, previously presented states of stress by a Mohr circle in the tau stress coordinates. Ini yang saya explain just now. So sometimes it is convenient to represent the state of stress by a stress point which has the coordinates sigma 1 minus sigma 3 over 2, sigma 1 plus sigma 3 over 2. So kalau you look at here, sigma 1 minus sigma 3 over 2 also similar to T in this TS coordinate, while sigma 1 plus sigma 3 over 2 is equal to S coordinate. Maknanya kalau kita nak gantikan daripada kita plot. Okay, hold on seconds. Okay, bila you tengok kat sini kita dah plot kalau kita tak nak present kita punya stress coordinate dalam sigma tau dan juga this one, kita boleh presentkan dalam bentuk coordinate T dan juga S. Okay. For many situations in geotechnical engineering, we assume sigma 1 and sigma 3 act on vertical and horizontal planes. So the coordinates of the stress point became sigma V minus sigma H over 2 and sigma V plus sigma H plus over 2. Okay, this one is also similar. Kalau you tengok sini what is sigma V? What is the sigma H? Sigma V is a vertical stress. Maknanya kalau vertical stress ni, kalau kita buat experimental in lab it's equal dengan axial load. Sebab axial load tu adalah daya yang kita kenakan secara menegak bila kita buat penambahan beban lah. Remember bila you buat trial as a test ke either one UU, CU or CD, you akan ada satu plunger yang mana pada bahagian atas tu kita increase loading, you akan nampak by the time increase load, samples are starting to fail. Maknanya dia start bagi until dia meet to the failure point, dia akan collapse, ataupun dalam case sample ni dia akan menunjukkan some sort of crack on surface lah. And then when you have the sigma H ni is equal to the horizontal stress. Horizontal stress ni kalau you represent in the soil mass condition, dia dalam keadaan horizontal, dalam keadaan laterally. Tapi bila kita buat sampling, testing, sigma H is also known as a sigma 3. Okay, sigma 3. Sigma 3 kita ni pun dia tengok keadaan. Kalau you conduct on the UU, unconfined compression unconsolidated undrained macam soalan tadi tu, yang mana sigma 3U equal to 0. Tapi kalau you buat try as a test selain daripada UU, you may have the different value of sigma 3. So sigma 3 dia boleh jadi dari 50, 100 hingga 150. The purpose what we are doing having this difference value between sigma 3 dan sigma 1, you akan nampak most of the time our sigma V or sigma 1 is larger than sigma 3 or sigma H. That's the things. So bila you pergi balik in the initial notes atau chapter chapter 1 ni, you akan nampak lah untuk week 2 dan juga week 3 macam mana kita menunjukkan the stress of the soil bila you kenakan beban ataupun bila you tak kenakan beban, and then you present the soil on sites tu untuk you dapatkan dia punya behavior by simulation. In lab, you akan replicate the stress on site to the stress at lab. So you akan nampaklah dia punya perbezaan daripada stress value yang betul-betul ada pada in situ condition dan juga stress value pada lab conditions. So for simplicity, we define that the T as what we have here, and then as what we got from here. Okay, sorry. For next slide, kita pergi seterusnya. Okay, the use of stress pulse. When we want to show successive stress, state of the stress, which are test specimen lab or typical element in the field undergoes during loading or unloading. Ini yang saya bagi tahu macam mana lah kita nak orang kata apa, nak simulate on site punya conditions, kemudian kita nak bawakan dengan lab punya conditions, bila you kenakan beban and then bila you release loading, what will happen. Okay, one way to use a diagram showing the successive states with a series of more circles. So more circle ni kalau kita nak plot stress pulse, dia lagi banyak, lagi cantik kalau you ada a lot of testing, sample testing untuk represent the more circles supaya dia boleh bagi you the directions of the stress pulse tu kat mana. Okay, for example, in a tricer test with constant sigma 3 and sigma h, okay, this is what you have. Saya said earlier lah, kalau you dah tahu sigma 3 you apa, sigma 1 you apa for the first sample, yang when you start a testing, tricer test for example, and then for sample B, you kenakan different value of the sigma 1 for example by assuming that sigma 3 constant throughout the samples A to D, and then when you plot the graph, you may have the maximum maximum stress point for A, B, C and D. Later you connect all the points at A, B and C that produce to you a stress pulse. Maknanya dia transform from the curve from the plot A to the curve plot B. So kat sini kita nampaklah kan di mana you punya stress pulse ni dia boleh presented in the T and S coordinate ataupun dia boleh plot dalam PQ coordinate. Okay, this is the conditions where you have the initial conditions of the stress, kemudian you kenakan beban. Okay, during the loading or unloading, you may see that what is the delta here is the increment stress before and after. Maknanya you dapatkan dia punya difference. Berapa perbezaan stress in horizontal pada keadaan asal initial conditions ataupun selepas you kenakan beban atau you alihkan beban. So kita nak tengok the difference there. From the difference pun, they can give you the stress pulse graphical point of view lah. Contoh kalau you have the similar sigma H, delta sigma H and also delta sigma V, for A here, you akan nampak lah the value pulse untuk A tu benda yang sama. Kat situlah delta sigma H, kat situlah juga delta sigma V. Kalau kata conditions for B, yang mana stress pulse dia dengan internal friction angle is 18.4, you will see that the delta sigma H is a half daripada delta sigma V. So yang ni yang saya kata kalau you tengok comparison between the sigma V dan juga sigma H, selalunya sigma H is lesser than sigma V. Same goes to the delta. Delta ni adalah difference sebelum dan selepas. Kemudian kalau kata you increase the internal friction angle to the 45, this one 45 kat sini is not calling the internal friction angle, dia panggil theta, failure angle. So the failure angle from 18.8 to 45 to the 90 degrees and less to the 45, you akan nampak dia punya the stress pulse that created from the different conditions during loading or unloading. So kat mana delta H kita positif, where the condition your delta sigma V negative, and where is your condition the delta sigma V is equal to 0. For example here E kat sini, delta sigma V kita sama dengan kosong. Kenapa delta sigma V kosong? So you need to think lah. Kalau look at to the direction sigma V itu adalah daya yang you kenakan daripada arah menegak. Meanwhile the delta sigma H is to the condition is horizontal. So remember this one is taking bila you ambil keadaan tu similar in the state of coordinates lah, mana yang you tengok. Okay, in the field macam mana kita nak replicate the stress pass in the field to the lab So this is the soil mass as you can have in certain depth of H, and then the soil mass is A subjected to stresses from V dan juga H vertically and horizontally. So when you have this sign is represented is effective. Kenapa effective? Kat sini you akan nampak dah this is the groundwater table at the ground surface. Kemudian macam ni kita nak dapat effectively, kita kena tolaklah gamma saturated dengan gamma water. You can have that sigma H is a K naught times dengan effective sigma V. So yang ni adalah formula yang you dah pernah lihat previous class. I mean that in the soil mechanics, geotechnics. Macam mana kita nak tengok because stress pass ni dia relate dengan coefficients of the earth pressure. K naught sama ada dia dalam keadaan aktif ataupun dia dalam keadaan pasif ataupun dia dalam keadaan rest. K naught represent earth pressure at rest. Maknanya tegasan tu ada tapi dia tak dikenakan sebarang beban, loading tak berlaku, unload pun tak berlaku. So this is the coefficient of lateral earth pressure at rest, K naught. So for this what we call here is that the common number K naught at rest for normal consolidated clay is 0.5. What this parameter important to you is due to the design stage. Bila you nak buat analysis, remember our course here is EG612 is about advanced geotechnical engineering. So it more relates kepada PO2 dengan PO3 yang mana you have to design certain of applications, geotechnical applications. So as you remember, bila you have this K naught value, dia sama ada dalam keadaan consolidations ataupun you nak tengok application dalam retaining wall. So kita akan menggunakan nilai K naught. So K naught ni you kena tengok lah for normal consolidated clay and then kepada over consolidated clay berapa nilai K naught. Awak rasa okay, for example K naught juga kita boleh calculate menggunakan satu formula Jackie formula if I'm not mistaken in which year 1940 something 1 minus sin phi. So yang ni pun alternatively lah macam mana kita nak dapatkan nilai K naught kalau kata some problems given to you without mentioning the soil conditions, soil history dan juga dia punya soil type. Okay, normal consolidated clays ni, if you remember in order to identify the strength of the soil sama ada dia residual, ultimate, peak strength, etc. Contohnya kan untuk tanah soft clay, fine clay dia akan bagi tahu the conditions of the soil. Over consolidated clay, normal consolidated clay ni macam mana. So you have to return back to textbook, need to define what is the over consolidated clay, what is a normal consolidated clay, what is a under consolidated clay. So ini semua what we dia relates kepada history of the clay. Macam mana clay tu mengalami tegasan berkurangan by the time ataupun by the condition itself from the undrained to drain, from the loading to unload. So all those things are important for fine soil lah especially. Okay, for heavily over consolidated clay or very dense sand, K naught is more than 1. In the stress space, the starting point of the stress pass indicated as the point A. Okay, this is kalau kata what is the point A, you boleh tengok point A is the maximum stress on curve. Itu adalah point A. So bila you nak tahu macam mana kita nak plot dia punya stress pass, you get first dia punya nilai tegasan maksimum pada lengkung tersebut. Okay, let's see what happens when we apply drain loading to the soil. Okay. Macam mana pula keadaan kalau dia loading dengan kita ambil stress condition in the field. Okay, something that similar initial condition. So yang ni adalah initial condition. Okay, yang ni adalah during you apply load. Okay, what will happen to the stress pass? But kita nak, we will concern on the stress pass. Stress pass ni dia tells you the story of the stress subjected on to the soil. So we want to see that how it behave before dia mengalami failure, for example. Okay, the effective overburden stress is increased and the remaining constant for horizontal effective stress. So when the soil element A undergoes axial compression, so nampak kan kat sini dia kenakan penambahan tegasan dalam arah vertical. The stress pass for the loading is shown as the red line. So this is the point where it is indicate to you the additional of the stress that applied here. So the soil element fails when it reaches the KF line. KF line is related to more column envelope but not the same line. So yang ni nak kata kat dia, nak kata kat sini KF line ni dia bukan this one kita panggil sebagai KF line. So KF line is not similar dengan failure envelope yang kita dapat daripada formula tau sama dengan C sigma N tangent phi plus C. Okay, dia nak kata hak tu. So KF ni you akan dapat bila you ada few samples ataupun few stress conditions yang mana dia increase. Dalam kes ni kita assume sigma H kita adalah constant. So bila dia constant, maknanya yang bertambah tu adalah effective vertical stress. So daripada point A dia akan create kepada point B. Dia akan create kepada point C. Kemudian dia akan create kepada point D. Sehinggalah dia bertemu kepada KF line. That is the meaning of the failure line for the stress pass. So please make sure that you are not get confused between the failure envelope dan juga KF line. Okay, remember we are talking in the TS stress pass dalam koordinat T dan juga S. So what is the T just now? T is a sigma 1 minus sigma apa dia? Aizudin? Apa nak kata tadi? T tu apa? S tu apa? Aizudin lah. T tu apa?
T formula tolak tu. S yang tambah tu.
T tambah ke? Cuba check balik. Okay, kena ingatlah Nah, T dia tolak. T iaitu sigma V minus sigma H over 2. S is a sigma 1 plus sigma 3 over 2. So please remember what we say here is the formula, what is the T and then what is the S. Okay, the next one is on the simulations for conditions. Same case here, sama lagi. Cuma kita nak pergi kepada unloading pula. Macam mana dia dalam keadaan unload. Just now is the loading Bila loading you akan nampak the increment in the additional vertical stress. Sehinggalah sampai satu tahap bila you kenakan beban tambahan tu, dia reach to the KF line. So we know that the samples or the soil at sites tu they dah reach to the failure. How about unloading? Unloading ni one of example dia adalah excavations. So bila kita buat excavation process it means that you unload, you reduce the loading on sites lah. Maknanya tegasan yang dialami oleh tanah tu dia mengalami pengurangan. So what you can have is the vice versa from the loading conditions. You can see that right now the effective vertical stress getting lower or decreased, but the sigma H remain constant. So soil element A undergoes axial extension due to unloading. Stress pass for the loading is shown as the green line, and then the soil element fails when it reaches the KF line for extensions. So during this time, you may see that the difference between extension and also the compressions. As you remember, soil ni dia ada satu karakteristik dia, dia mengambil tegasan dalam keadaan compressions. and then dia bersifat incompressible. Dia the soil is a unique because dia tak macam concrete ataupun any structure any material such as steel, ataupun kalau you ambil sampel example yang dulu kalau kita nak relate coleslaw is a rubber. By looking at the rubber relationship, when you compress, the rubber can turn to the original shape. It means that there ada some elastic behavior. However, bila you play around with the soil, sorry again. Okay, I think hold on for seconds. That I let me break 5 minutes. Why?
Boleh.
Okay, really sorry about the noises and disturbance occur just now. Okay, yang ni kan bila saya ajar, saya rasa every one of you has a lot of experiences and knowledge in terms that you want to recall, refresh back what you have gained previously during the internship or during your class from year 1 until the part 7 or whatever parts you are here. There's a good thing that you can open up your mind to think about the geotechnical engineering itself. As I said, it is very my international friends say that geotechnical is something like a dynamic problems. There's no fixed solutions for whatever application that you may face in. For example, when you have a problems in slope stability, the problem can come again and again due to the factors. For example, raining. I mean that the failure can occur easily due to the heavily water contents of inside the water. Tapi bila you nak melihat dia dari segi solutions, we couldn't say that the solutions A is applicable to the current site problem. You may think that what are other options, solutions that could to be taken into considerations for the best solutions to tackle the problem on sites ataupun slope failure. That's why I said it is dynamic. There is no fixed solution. Whereby when you go to the something subject matter like a structural problems, the solutions is fixed. I think that the simplest way for everyone can see what's happening inside the concrete, for example. If you relate to the corrosions, everyone knows that corrosion is occur due to reactions oxygen between water, for example. Somehow, bila you relate kepada soil problems, kita ambil simple occurrence yang selalu berkerap berlaku di Malaysia adalah slope failure. Right now is the monsoon season. Bila monsoon season ni, all the public authorities already get ready lah kan. Apa kita nak kena bersedia? Contohnya Jepam kena get ready dengan dia punya boats dia punya facilities. Dia collaborate dengan JPS standby dengan update data water rainfall. Every day punya water rainfall reading tu berapa kan, just to aware that is that the water has reached to the critical ataupun failure level. If this thing happen, what's next to be done? I mean that dia kena keluarkan alarm. So something that bila you nak study dalam geotechnical ni, if you really interest on this topic, you need to think out what are the things and how to relate antara satu sama lain. You couldn't be a fixed like a robot. So you kena carilah what best solutions, what are the things happens to the failure, causes to the problems on site ataupun pada soil mass tu sendiri. For example, macam tadi kita cerita pasal loading kan. Loading ni senang je nak bagi example. You ada site clearance ataupun you ada original sites. You kenakan beban, you buatlah penetration ke apa ke, you dah subjected to additional load, you akan nampak the increment of the vertical stress. However, bila you nak relate pada stress bar dalam keadaan vice versa in unloading, for example, you akan nampak our effective vertical stress are getting decreased lah. I mean that kalau you tengok in terms of effective depth pun H dia dah makin berkurangan. How then we relate to dia punya T and S stress pass represent the failure point. So the stress pass is the simplest way to represent the failure of the samples. Okay, kalau kata macam kita tengok dekat graph stress strain, yang tu kita hanya dapat satu lengkung biasa. Daripada lengkung biasa tu kita nak kena transform pula graph kepada lengkung kepada garis lurus shear versus shear stress versus normal stress untuk dapatkan dia punya value of the strength. But this one is bila you relate dengan pore water pressure. Somehow bila complex problem dalam soil, bila melibatkan pore water pressure, excess pore water pressure, lebihan air, semua kandungan air fully saturated ataupun over what we call it partially saturated. So benda tu dia tak boleh senang nak represent kan. So somehow they can represent it using the stress pass lah. So this is what I try to explain. And then look at to one example here, kalau you ada triaxial test. So triaxial test ni adalah, if you remember back macam mana kita buat triaxial test ni, dia ada 3 kategori triaxial test, sama ada you buat UU, CU ataupun CD. Dia punya apparatus, arrangement of the apparatus lebih kurang macam ni. You ada membrane, you ada porous filter, kemudian you ada pressure water chamber, and then you ada some drainage line. Okay, kat mana sigma V, sigma H dia dah boleh nampak kat sini kan. On top of it adalah vertical stress atau kita panggil sebagai axial load. On the surrounding for the chamber, yang daya di sekeliling chamber ni kita panggil dia sebagai horizontal stress ataupun confining stress. Sebenarnya bila you tengok ni dia dalam 2 dimensions, sebenarnya dia can represent dalam 3 dimensions. So in reality awak punya silinder tu bentuk okay, sorry again. Okay, back to our discussion just now, triaxial cell. Okay, yang ni yang berlaku. Yang mana saya kata kalau dia menceritakan 2 stages in triaxial. If you remember, dalam triaxial ni dia melibatkan 2 stages. The first stages kita panggil sebagai consolidations. Consolidations proses di mana dia dalam fasa tu dia kalau you buat sampel yang melibatkan air, during this time kita akan penuhkan chamber kita dengan air. And after in the second stage dia melibatkan sharing. Sharing itulah kita nak tengok the failure of the samples. Okay, for here they shows you that kalau keadaan A ni bagaimana. This one yang kita kaitkan dengan stage 1 iaitu consolidations. So sample is consolidated, kita letakkan, kita kenakan fully drain, and in the B figures here shows you the compression sharing yang mana drainage valve closed and then the pore pressure can be measured during this time, and at certain time bila you allow for dissipate of the pore water pressure. So maknanya drainage valve ni kita boleh buka dengan tutup lah, bergantung kepada the purpose of the experimental awak tu, triaxial awak tu jenis apa, CU ke CD. Itu yang maksud dekat gambar sini. Okay, how do we relate dengan pore pressure? Remember as I explained, bila you have a time untuk read in the textbook, you go to the textbook with clue chapter stress pass dalam ke surat 261 something, kemudian you buka juga shear strength. This is how it relates to you, macam mana stress pass can be represented in the failure of the triaxial samples. Okay, and then they relate juga how to measure the pore pressure parameters. So this is the condition if you relate from the previous slide yang mana keadaan pertama ni kita kenakan consolidations, dia akan ada changes in the stress 1 dan juga changes in the stress 3, This is undrained loading of samples. Kemudian effect of the confining pressure ni, you akan nampak keadaan di mana if you remember again the total stress dengan effective stress, dia benda yang you boleh apply semula untuk dapatkan the pore pressure, sama ada untuk undrained dan juga drain. So in this case when you want to calculate the pore water pressures, is pore water pressures is the difference between the same stress. Contohnya you nak tahu antara undrained effective stress dengan total stress. You want to know the U pore water pressure. So the pore water pressure, kalau kita look at balik to the formula, effective stress 1 is equal to total stress 1 minus dengan pore water pressure. In order to get the pore water pressure, U is equal to total stress 1 minus dengan plus total stress 1 plus dengan effective stress 1. So remember balik, kalau kata you want to calculate the effective stress 1 is equal to total stress 1 minus dengan pore water pressure. So kalau you nak dapatkan pore water pressure sama dengan effective 1 plus dengan effective 1. So the pore water pressure ni you can measure in horizontally dan juga vertically, maknanya dia ada U in sigma 1, U juga untuk sigma 3. Okay, dalam pore water pressure ni they give you a parameters B dan juga parameter A. So delta U is a B times dengan delta sigma 3 plus B dot A changes or difference in delta sigma 1 minus delta sigma 3. So back to these elements yang ni menunjukkan macam mana keadaan di mana kita can relate the effect of the confining pressure antara consolidation stage dan juga sharing stage lah. So this is the confining pressure, keadaan pada mula, kemudian bila you kenakan sharing, you nak tengok dia punya pore water pressure ni berapa kan. So you can calculate dia punya formula dengan cara, as I said lah, if you represented dalam bentuk sebutan stress, kita akan dapatlah sigma 1 campur dengan effective sigma 1. And later on, how to determine the parameter A and B. Okay, yang ni for example they give you a simple case for saturated dan juga elastic. As I mentioned in the earlier class, kalau you study in the soil mechanics, you akan nampak the behavior of soil is not as a linear itself. Dia bukan sekadar linear saja, ataupun dia bukanlah bersifat elastik. They can present to you elastic dan juga perfectly plastic. Ini adalah simple case. Somehow dia boleh juga represent you dalam bentuk hardening, ataupun dia boleh jadi dalam bentuk softening. So ini antara topik awal pada minggu pertama berkaitan dengan discuss untuk chapter 1. How do we get the B and A? So these are the typical values untuk different parameters of the soil. Actually untuk you calculate B dan juga A for saturated soil, we can see that B is equal to 1 and then A is a delta U minus dengan delta sigma 3 bahagi dengan delta sigma 1 minus dengan delta sigma 3. So what is a A? A is a function of soil properties ataupun stress history. So sometimes the typical value A is given here dengan andaian B sama dengan 1. But somehow B ni juga dia boleh berubahlah bergantung kepada keadaan. Kalau kata you ada linear elastic soil, A kita boleh ambil daripada this value juga lah. Triaxial compression is 0.33 and plane strain is 0.5. Okay, next one is undrained triaxial test stress pass on a linear elastic material. Okay, remember yang ni kita assume sebagai linear elastic material. How if the material behave as a linear elastic perfectly plastic? So mungkin yang explanations kat sini dah tak applicable. Whatever it is, it try to give you a simple understanding explanations how to get the stress pass untuk undrained triaxial test dengan material yang bersifat elastik. So remember, in the early chapter, I also explained to you, bila kita cerita the behavior of the soil, we want to see dia punya deformations. So deformations. And then we want to see dia punya failure, stability. So the deformations can be related to the elastic stiffness, E ataupun G ataupun nilai K. What is the E? So you tengok balik lah. Meanwhile, from stability ataupun dia punya strength of the soil can be presented from the parameter C dan juga parameter V. Yang ni saya belum lagi cerita macam mana Kg dan E boleh dikaitkan dengan Poisson ratio, boleh dikaitkan dengan compressibility parameters. So bear in mind when you when you want to study about the soil mechanics ataupun soil behavior and failure, you kena look at from all aspects lah. Contohnya nilai CV kita dalam keadaan unload, loading, kemudian dalam keadaan undrain ataupun drain. How about the parameters, effective total stress ataupun total stress parameters. All those things kena ambil kisah lah. Kalau kata you melibatkan soft soil such as clay, silt, or that part you have to consider also dia punya history consolidated dia. Adakah dia NC ataupun dia adalah over consolidated clay, and then what are the value untuk this kind kalau dia melibatkan K1, K0, KV dan juga KH. Okay, back to here. In order to determine the stress pass in the T and S, if you have the total stress incremental parameters, the incremental here indicates to you the symbol of the delta. So bila you diberi soalan what is the incremental total stress parameter, maknanya you kena dapatkan delta S. What is a delta S? So you have to know lah apa nilai S, initial condition dan juga final conditions. So for this case, the same formula juga kita pakai. The only difference is that due to the incremental, so semua formula asal dia berubah. Formula asal dia S adalah sigma 1 plus dengan sigma 3 bahagi dengan 2. Kalau kata T pula, sigma asal dia adalah sigma 1 tolak sigma 3 bahagi 2. Ini kalau dia tak melibatkan incremental stress. Tapi kalau dia melibatkan incremental, so the original formula change to the additional one lah dengan incremental symbol. So the effective stress, same thing. The only difference is that the symbol here. Cumanya you kena tahulah sebelum dia boleh nak dapatkan design dia akan kaitkan dengan keadaan di mana delta sigma effective 1 is also equal to delta sigma 1 minus dengan delta U. Itu yang you have to be careful. So all these things will be in the delta incremental. And remember back the effective stress adalah total stress minus dengan per water pressure. So kalau dia minta incremental effective stress, maknanya incremental total stress minus dengan incremental per water pressure. So the total stress pass can be readily deduced by setting delta sigma 3 equal to 0, which leads to delta T over Ts equal to 1. So for this case, let's say dia assume yang ni sama dengan kosong, yang ni sama dengan kosong. So finally this is what we have in the total stress pass. Okay, in other words, the total stress pass is a straight line with a gradient of 1. To obtain the effective stress pass, we need to consider excess pore water pressure generation. We know from this term pore pressure, the equation B equal to 1 and A is wanted for elastic saturated material. So that the delta U is equal to delta 3 plus dengan delta minus 1 minus B. Okay, mana datang 1/3 ni? So remember balik daripada kita punya slide previously. Okay, yang ni yang dia bagi tahu. Delta U is equal to B delta sigma 3 plus B dot A times dengan difference delta sigma 1 minus dengan delta sigma 3. So yang ni sebabkan dia elastic material, saturated material, dia dah bagi tahu A sama dengan 1/3. So you just replace sajalah. B kat sini dia dah hilang sebab dia sama dengan 1. Remember balik formula untuk dapatkan delta U. So bila dia rearrange balik these equations untuk dapatkan in the stress path punya coordinate iaitu S dan juga T, finally what it has from here is that the effective delta S is equal to 1/3 delta 3, yang mana delta T over delta effective S is equal to 3. So macam mana dapat 3 ni? You fikirlah, sebenarnya dia adalah cross multiplying sajalah. So yang penting dia deriving, how it is derived from the pore water pressure, kemudian dia tukar dalam sebutan delta sigma 1, delta sigma 3, and then how do it relates dengan S dan juga T, barulah they can produce to you that the delta T over delta S prime sama dengan 3. So remember sebenarnya kalau you perasan balik kan, sebenarnya dalam sebahagian kat sini pun dia dah bagi tahu dah dia punya formula. You kena tengok balik lah kan. Delta S tu apa? Delta S adalah delta sigma 1 tolak dengan delta sigma 3 bagi dengan 2. So dia replace, dia dah gantikan semula. So looking back to here, yang delta S ni adalah plus. So looking back to here, they can have that from here, delta 3 minus delta U ni is actually representing dalam sebutan T kalau you susun semula. Mana U ni sebab dia adalah efektif. So kita nak dapatkan dia punya efektif, kita kena tolak dengan U. So this is how it is showing to you how the conversions from the vertical stress, horizontal stress to the stress pulse coordinate. Okay, the explanation actually explain to you, this is the figure, the image. Macam mana the sampling from the experimental results plot in the stress pulse coordinate, and then they can also represented in the Q dan juga P. If you look at here, kat sini adalah P, kat sini adalah Q. Just now I explain antara S dan juga T kan, kalau you perasan balik. So it's also same, yang mana stress pulse ni dia boleh diplot dalam sebutan Q dan juga dalam sebutan P. P ni adalah mean stress lah. Kalau you tengok mean stress, dia tambah bagi dengan 2 purata. Yang Q ni adalah average deviated stress, yang mana dia tolak sigma 1 tolak sigma 2, sigma 1 tolak sigma 3 bagi dengan 2. So kalau you tengok sini juga, dia dah tak ada dah Mohr circle. Kenapa Mohr circle tu hilang? Sebab dia dah gantikan dengan stress path. Jadi kalau kita plot balik, kita akan dapatlah 1, 2, 3. That is the stress path. Sorry, that is a Mohr circle. Okay, go to first example here. If you have a problem, a cohesionless soil specimen is isotropic consolidated to 100 kPa and is then filled by increasing sigma 1 and sigma 3 such that delta sigma 3 is a 1/3 delta sigma 1. Determine final S and final T at the failure state. The slope of the KF line is a 20 degree. Okay, dalam kes ni, dia dah bagi garis kegagalan untuk stress path tersebut iaitu 20 darjah. How are we going to solve that one? You can see from here is that the initial state is given by the formula, by the informations. Kalau you tengok tadi, dia dah bagi informasi yang mana isotropic consolidated is 100 kPa. Okay, itu adalah makluman untuk sigma 1 plus sigma 3 bagi 2, iaitu S as a 100 kPa. So untuk dapatkan seterusnya T ni adalah makluman yang dibagi pada awak di sini adalah iaitu okay, it tells you, it inform you that the then filled by increasing sigma 1 and sigma 3 such that delta sigma 3 is equal to 1/3 delta sigma 1. So when you set back balik such as no informations for T, so we can set here T is equal to 0. So at the sharing stage, bila you kenakan sharing untuk kita nak dapatkan the failure of the samples, so the information first bagi tahu delta T sama dengan delta sigma 1 minus delta sigma 3 bagi 2 sama dengan 1/3 delta sigma 1. So of course kalau kata delta T 1/3 delta sigma 1, so delta S adalah 2/3 daripada delta sigma 1. Therefore, bila kita nak dapatkan dia punya hubungan delta T over delta S, we have the 1/2. Okay, how do we get this one untuk kita relatekan dia? Sebab kita nak dapatkan dia punya the T value dan juga the S value. Okay, dalam ni dia minta apa? Determine SF dan juga TF at the final state. So, in order to get that one, you kena plot. So, kita kaitkan one equation yang mana T sama dengan S tangent 20. Mana dapat 20? 20 ni adalah failure line KF. Dia punya angle 20 darjah. Dia dah bagi tahu tadi dalam soalan. So, kita gantikan balik S ni. Okay, sorry. So, another equations daripada problem ni, kita dapat juga T sama dengan 0.5 darab S minus dengan 100. So, sebenarnya kan soalan ni dia dekat bahagian bawah ni saya ada letak juga maklumat ni. At this side saya tak boleh nak view. Tapi you akan nampak lah macam mana equation 1, equation 2 terhasil. Yang ni adalah equation 1, manakala yang ni adalah equation 2. That's why equation 2 kat sini you akan nampak T sama dengan 0.5. Yang ni adalah 100 sebab dia dah bagi tahu kan pada failure tu kita ada S sama dengan 100. So 100 minus dengan S. Yang ni adalah S. So that the second equation. So bila kita samakan equation 1 sama dengan equation 2, finally you akan dapat first of all you akan dapat nilai S dulu. Sebab tadi kita dah samakan T1, kita dah samakan equation 1 sama dengan equation 2, so you akan susun balik lah S prime tangent phi 20 sama dengan 0.5 S minus 100. So S effective is a 367.65 kPa. Meanwhile, untuk nak dapatkan T ni, you can insert in any one of these equations. Sama ada you nak gantikan nilai S ni dalam equation 1 ataupun equation 2, you akan dapat the same one. So this is how the applications of the stress pass untuk you kaitkan the conceptual, theoretical to the problematic. And go to the next one. Just now kita look at from the simple view explanations untuk elastic sample, linear elastic material of the sample. Okay, from the previous example, consider the CU test carried out on the third sample, cell pressure 600 kPa. Because of undrained condition during test, the excess pore water pressure is generated. So ini adalah informasi berlainan. Maknanya kat sini bila ada excess pore water pressure, automatically you akan dapat delta U. So how to get delta U? You kena dapatkan informasi berkaitan dengan delta sigma efektif 1. Kemudian dia kena minus dengan sini dia kena minus dengan delta sigma 1, dan you kena tahu juga delta dekat sigma 3 dan juga delta efektif sigma 3 dan juga delta sigma 3. Sebab if you look at closely to this one, actually bila kita nak plot stress pass, kita hanya nak represent this line saja, yang black line, ESP dan juga total stress pass. So bila case condition consolidated undrained, yang mana you akan ada stress pass in ESP dan juga TSP. T is the total stress pass, E effective stress pass. However, to shows in simple way, so they explain to you dengan graph tau versus sigma. This gives rise to one, a total stress pass and effective stress pass, in which ESP is equal to TSP minus dengan delta final pore pressure. So another relationship untuk you relatekan antara failure line untuk Mohr circle dan juga stress pass, we can use this one. Okay, this is the example. Okay, kalau you perasan the phi here is coming up from the formula sin phi. Kalau you plot kat sini, dia ada kaitan dengan tau sama dengan C plus sigma N tangent phi tu. Okay, yang ni pula dia berkaitan dengan stress pass KF line. So that's why yang ni dia denoted dengan effective alpha. So how to relate these two lines antara KF line dengan failure envelope tu? Failure Mohr circle tu. Nampak tak yang ni adalah Mohr circle, yang ni pun adalah Mohr circle. So they touch the Mohr circle, that is the failure of the Mohr circle. So the relationship can be related dengan sin effective phi dan juga tangent effective alpha. So again, before you can have the what we call it here, untuk dapatkan data UF ataupun vice versa, you can ada information berkaitan dengan initial stress dan juga final stress. So initial stress, final stress untuk effect untuk horizontally ataupun vertically can give to you the delta in sigma 1 dan juga delta sigma 3. Tapi bila you kaitkan dengan excess pore water pressure, so finally dia boleh dia can have to you the difference in between, yang mana kalau kata kita nak dapatkan efektif sama ada efektif 1 ataupun efektif 3, kita akan tolak daripada total stress dengan pore water pressure. So this is how it means that when you plot all this between circle in total stress dan juga effective stress, you akan have one line connections ataupun kita panggil dia sebagai stress path. This one is the maximum stress for curve red. Here is the maximum stress at curve blue, and here is the maximum point dekat curve green. So they connect all this point from here dengan andaian sigma 3 is a constant from sample red, sample green to sample blue. So you can have one stress path dalam total stress. And then in order to relate dengan effective stress path, whereby the equation is given here, effective stress path is equal to total stress path minus dengan delta UF. So we can get that once. Maknanya kita tolak lah kan, kalau kata tadi kita nak dapatkan total stress path, kita dah tahu berapa. Let's say kita nak dapatkan ESP, so kita kena buatlah total stress path tolak dengan delta UF. So every this curve untuk effective stress path can be obtained from the formula here. So the other way lah untuk you dapatkan the value ataupun curve untuk ESP, effective stress path conditions. Okay, this one is another example from the final exams. A consolidated Andrean triaxial compression test. So bila dia ada maklumat Andrean triaxial compression test, automatically dia melibatkan pore water pressure. On sample saturated clay, the sample has been isotropically consolidated so that start of the test sigma 1 effective, sigma effective 3 sama dengan 25 kPa. The slope of the KF line is 30 degree. Use the stress path method to determine the value of excess stress. And when the effective stress path intersect the KF line to cause shearing failure of the sample, assume the pore pressure parameter at failure is 1. Okay, how are we going to solve this problem? Okay, this is the solutions where you can have at first one kita dapatkan dulu dia punya point dekat koordinat dia, yang mana dalam conditions ni sigma efektif 1 plus sigma efektif 3 over 2 yang iaitu sama dengan S adalah 25. Okay, yang ni maklumat ni memang ada dalam soalan. So S kita 25, T kita sama dengan 0. Okay, this one is the first point. Apa tujuan point ni? Tujuan point ni untuk you plot atas paksi. Ini adalah point yang kita dapat, iaitu 25, 0. T 0, apa ni? Sorry, terbalik ni. Dia bukan sini sepatutnya. Simetri multiplas kan? Okay, sini sepatutnya T dan juga S. Okay, T25 S sama dengan kosong. Ini terbalik. Ini sepatutnya T, ni adalah S. So bila you plot kat sini, dia bagi tahu maklumat juga at the failure, effective sigma 3 failure is equal to effective total confining failure sama dengan effective 3 at start 25 kPa. So parameter A, sebabkan kita ada pore water pressure is 1, so the final pore water pressure over Q is 1, so UF is equal to Q. So the Q dalam kes ni, UF is equal to Q. So dia plot balik untuk dapatkan what is the Q value dan juga what is the axial stress. By using the equations, if you go to this point bila kita plot, kat sini kita punya permulaan 25. And we know that this one is a Q over 2. And here is similar as a Q over 2. Okay, yang ni pun adalah Q over 2. Remaining ni adalah 25 minus dengan Q over 2. Ini ibarat kata dia main coordinates lah. So that untuk dapatkan the first equation ni, tangent 30 darjah, tangent, what is the tangent? Q over 2, 25 minus dengan Q over 2. Maknanya kita nak tahu dia punya tangent Q over 2 tentangan bahagi dengan this one, opposite bagi dengan dia punya sideness dia. So dia akan dapat Q over 2 times 25 minus Q over 2. So tangent 30 you tukar berapa nilai dia. So kita akan dapat Q over 25 minus 0.5 Q. So finally the Q is 18.3. In order to get the axial stress, so dalam this one dia bagi effective 1 plus dengan increment sigma V. Sigma V ni dalam kes ni dia sama dengan Q. Okay. So 25 plus dengan 18.3. So we have the answer for axial stress sama dengan 43.3. So for axial stress ni adalah daya yang you kenakan masa you letak atas chamber tu. Berapa nilai tegasan yang kita apply to the sample. So because of this one, dia ada effect of the pore water pressure. So sigma 1 sama dengan efektif 1 campur dengan U. Dalam kes ni dia dah bagi tahu U sama dengan Q. That's why we have to define what is the Q. Once you get the Q is an 18.3, so you just tambah. Initial tadi ataupun effective stress sigma 1 kita dah tahu dah 25. 25 plus balik dengan Q iaitu 18.3. So the final axial stress yang dikenakan ke atas sampel ni adalah 43.3 kPa. Ini untuk stress pass CU test. So as before, macam mana kalau this time kita ada nilai C pula. So tadi kalau you perasan C kita sama dengan kosong. So kita ada some relation antara sin phi dan juga tangent phi. But this time bila you nak kaitkan when you have the effective coefficients, so we need to relate how it transform atau how to relate antara this black line dengan red line iaitu KF line dan juga failure envelope line. Okay, in this part, in order to get the C, you can have that effective A over cos effective phi. So please look at closely the formula and understand what is the phi kat mana, A tu di mana, alpha tu apa. Supaya nanti you tak salah gunalah. Okay, interpretation of pore pressure parameter A from stress pass. Yang ni pun the same thing juga how it is defined and how it is relates. Initially kita ada daripada total stress pass untuk kita dapatkan ESP ni. Remember just now the formula is TSP minus dengan delta U. So delta U ni is a difference antara pore water pressure dalam condition total stress pass dan juga effective stress pass. Okay, try axial space. Ini yang kita relate dalam 3 dimensions lah. you can see that stress in YY is equal to vertical strain. Kalau you ada strain in XX is equal to strain in horizontal. So this is represent to you the two independent components of stress and strain. So in somehow stress tu they can represented in the components in X dan juga components in Y. Tapi bila kita buat experimental ataupun selalu kita buat notations, always kita use a simple one as a sigma V dan juga sigma H. So on this part bila yang ni you kena look at to the samples ataupun space sampling tu dalam in which condition, sama ada in isometric ataupun triaxial space. If you get involved in numerical modelling bila you nak model dalam software, for the first step iaitu geometry model they will ask you whether you want to draw your model in 2D ataupun 3D, plane strain ataupun plane stress or axis metric. Somehow what are differences between this one contohnya kalau you ambil plane strain, you ambil plane stress ataupun you ambil asymmetry, dia punya stress component assumptions tu yang berbeza. So they will finally affect to the final results bila you buat simulations. So final results tu lah yang menceritakan kepada awak adakah input for the first one you set tu you masukkan betul ataupun salah. So other way is that bila kita nak represent the stress pass components ni dalam PQ stress pass state. Tadi kan saya tunjuk dia boleh represent dalam ST ataupun PQ kan. So the similar can find from here effective P mean stress sama dengan 1/3 sigma V plus dengan 2 sigma effective H, while Q is the derivative stress is the effective V minus dengan effective H. So the volumetric strain ni bila you kaitkan dengan changes of the materials shape, dia mengalami deformations in term of the changes in volume. So you nak tengok apa perbezaan volume dia dari vertically dan juga horizontally. Ini pun similarly kita nak look at to the S is what? So yang ni I will find out what is I think strain in shear ni. So linearly elastic stress strain relation kalau you buat in PQ state and you relate dengan stiffness material iaitu K dan juga G. K is the bulk modulus, G is the shear modulus, and then you relate dengan volumetric strain dan juga shear strain, you akan dapat this somehow equations. So that's what I said bila kita buat stress pass, sebenarnya kita dah represent stress strain dalam simple components ataupun convenient representation. Actually P itu adalah combination ataupun summations of the sigma V plus dengan effective to sigma H over 3. Kalau kita nak tunjuk satu-satu dipanjangkan. So yang ni lebih mudah lah ataupun lebih simplified. Okay, yang ni different ways juga how it is represent to you in the CIU test. Bila dah ada these conditions, of course you akan ada the delta U, the changes in pore occupation. The same goes, stress pass you akan ada total stress pass dan juga effective stress pass. Again, you kena tahu the relationship dia. Satu yang mewakili KF line, satu mewakili failure line. Okay, yang warna hijau ni menunjukkan stress pass untuk efektif. Warna merah ni menunjukkan total stress pass untuk yang warna merah ni adalah stress pass untuk total. So dalam kes ni the gradient of the slope is a 1 to 1. Vertical dia satu, horizontal dia pun satu. So you can know lah what exactly the angle of the KF line ni. So kita nak dapatkan dia punya KF line. This is the KF line. Okay, yang ni stress pass juga. The slope of the stress pass also can be represented dengan notation M. Okay, M ni pun adalah slope. Dia punya angle berapa. Kalau kata certain case untuk QP plane lah, atau kita panggil QP stress pass, you nak dapatkan dia punya slope, the gradient of the failure stress pass line ni, kita boleh pakai this formula. 6 sin phi efektif darab dengan 3 minus sin phi. Okay, ini cara lain lah untuk menunjukkan pada anda. Right now, we are heading to the Q dan juga P stress pass. Dia punya koordinat bukan lagi S dan juga T lah. Okay, ini untuk consolidated drain. Just now kita pergi consolidated undrain kan. Sekarang ni adalah drain. Okay, the more circles grow as the soil at A and B undergo drain shear until immobilized and drain strength of SDA and SDB. Okay, this is differences bila samples dalam keadaan consolidated drain. You can see that the stress pass also change in the samples for effective. Contohnya kalau sampel A dan juga sampel B, dia dah tak macam tadi kita tengok untuk undrain you boleh nampak on the same sample dia punya total stress kat situ, dia punya effective stress dia dekat on other side left. Tapi untuk dia punya cases contoh kita nak buat comparison untuk sampel A dan juga sampel B, this is how it shows to you and how it is relate on the stress between initial stress dan juga final stress for each sample A dan juga each sample B. What the things that you need to understand from here is that you bila tengok kat sini sample A dan juga sample B. Sample A adalah red color, sample B is a green color. At this time the sigma 3 is constant pada sample A dan juga sigma 3 pun also constant pada pada sample B. When the stress in sigma 3 constant and the axial stress is increased by load, you akan nampak at one time dia dah meet to the failure line. Same goes to the sample B. Yang ni kalau kita represent dalam more circle. Tapi kalau kita nak dapatkan dia punya stress pass, you have to connect antara circle 1 at the stress value antara sample 1, sample A pada kali kedua dan juga sample A pada kali ketiga. That is represent to you the stress pass untuk sample A. Same goes to sample B. You dapatkan dia punya maximum value at the curve pada sample yang pertama, sample B yang pertama, sample B yang kedua, sample B yang ketiga. You connect dia punya line ni, you akan dapat stress pass untuk sample B. Kalau kita presentkan balik dalam KF line this is the KF line. KF line tu mana datang tadi? Adalah connections antara from this point to this point. You ambil daripada origin. Okay, nampak tak sini? Kemudian what produced to you is a one angle here is alpha. Meanwhile, kalau you ambil daripada more circle tadi, you akan dapat internal friction angle phi. Okay, look at two different lines antara dash black line dan dengan full black line. Okay, yang ni full black line ni lah yang bagi pada awak maklumat the KF line. So for this part it says that this one you can have the effective stress pass is equal to total stress pass same to A and also same to B. And you can see that the STA at here and also STB. So yang ni maklumat yang dia bagi tahu kat sini. When more circle grows as the soil A and B undergo drain shear, it mobilizes the drain strength of SDA and SDB. Maknanya dia punya nilai tu berubah, bergerak daripada from this point to this point. That's why you can have that at sample A tu dia punya point last dia at this. And then bila pada sample B pula you kenakan consolidated drain test juga, you akan nampak dia punya failure ataupun stress at failure tu increase. So this is tells you the difference for different sample A dan juga B. At this time effective stress adalah sama untuk ES dan juga TS. So note with the relations tangent alpha is equal to sin effective alpha. Okay, yang ni untuk effective stress pass grain shearing. Apa yang berlaku bila dia dalam keadaan shearing? Tadi pun kita cerita juga grain conditions. Cuma kat situ, you akan nampak lah effective stress sama dengan total stress. So, what's happening during the shearing? Dalam shearing stage, we can see that this is the point where it is shows you the difference of the angle from the, okay. Okay, kat sini adalah satu conditions yang standard. Okay, the final one untuk connect antara this let's say the stress mobilized from the sample A to the sample B is given by the blue line here. So the standard range here as represented by the dark line here, same from here also. Kalau you look at this point, dia actually represent to you the stress sigma 1 dan juga stress at sigma 3. And same to here, bila dia connect how it is given to you the relations in terms of the angles, here can goes to this part and here is this part. So one thing can give you this angle, another side will give you different angle. That's why I said here is actually is a 1 and here is actually is a 3. Okay. So, kalau kita nak connectkan antara dua conditions tu, antara sigma 1 dan juga sigma 3, we can have one standard range shear line stress pass at this ataupun we can name here as a KF line. Okay, in summary, what's importance about the stress pass is, as I said, it's easy way to represent the failure of the samples. The only difference is that now kita nak kaitkan antara failure envelope dan juga stress pass line. And the conditions can be observed from the drain conditions ataupun undrained condition of the sample in total stress, more circle, ataupun in effective stress, more circle. The thing is that you may have the same KF line by considering the effective stress pass and total stress pass. And then ESP for undrained response and total stress pass for drain response. So ini keadaan di mana you akan dapat the same KF. Kat situlah ESP, kat situlah juga TSP. So that gives to you the same value of the KF line. Okay, what are the differences drain versus undrained? Okay, yang ni I think that dia just refresh balik lah apa yang kita dapat daripada previous experimental ataupun previous topic, just to refresh again. Dalam engineering, you need to take concerns between drain and undrained condition. The part is that the drainage, sama ada dia ada develop pore water pressure ataupun dia tak develop the pore water pressure. For which situation the excess pore water pressure cannot dissipate fast enough in the short term, whether it is sand or clay, so that is the undrained strength. So yang ni adalah common things yang mana bila kita nak relate dengan applications pun, sama ada you nak construct embankment ke, you nak construct retaining wall ke, you nak tengok shear strength ke, first you kena check dulu dia adalah short term stability ataupun long term stability. And then dia ada tak berkaitan dengan allowing for water to dissipate. Kalau you allow, maknanya dia adalah drain strength lah. And then kalau you not allow, cannot allow, so it is a undrained strength. It is very to have a right chosen, right appropriate decision sebelum you start design parameter mana yang nak guna. In a way is that to ensure the application sustain or stable for long term. For example, granular material like sand, we may use undrained strength to characterize behavior under very rapid loading, such as earthquake shaking. So yang ni relevant lah. Kalau you tengok behavior of the sand pun sendiri, dia adalah permeable material. So dia tak perlu pun pakai drain. So undrained pun dia dah enough. But that is a certain condition if you want to study the earthquake effect. When the time scale is too short to allow the excess water pressure to dissipate. So logically, memang kalau kata selalu kita faham population ni dia main dengan clay kan, tapi sometimes it also can be involved dengan sampel jenis sand granular. As I said lah, dia tengok kat mana application design you. Undrained strength is typically smaller than drain strength due to the presence of excess water pressure which tend to reduce the effective stress. So ini yang ni pun penting. With time, the stress excess water pressure will dissipate and the effective stress increase. Effective stress increase as the effective stresses increase, the shear strength also increase. So the shear strength will attain the drain strength value when all the excess water pressure has dissipated. So this is depending on the soil permeability and it takes very long time both drain and undrained. Yang ni yang saya mention just now, kalau logically yes, kita relatekan dengan sand just now, we totally understand and understood that sand is a highly permeable. Highly permeable, of course kita akan allow water to dissipate. But somehow in the application such as earthquake yang mana you want to study the effect of a very short time, kita nak tengok effect stability di dalam tempoh masa sekejap. So walaupun kita tahu sand ni adalah permeable material yang high water can dissipate dengan K yang tinggi, coefficient of hydraulic permeability, tapi sebabkan ni application ni kita tak nak tengok impact of the earthquake tu macam mana, so kita tak boleh analyse dia sebagai long term ataupun effective stress parameter or drain strength parameter. Kita kena consider dia sebagai undrained strength parameter dengan undrained conditions atau undrained strength. Okay, this is another things that you have to take note on the typical value for effective fee. Tadi kita tengok kan the relations antara failure envelope dan juga KF line. So it's very important to you that to aware the familiar parameters value untuk you guna in future, for example. Other than that, we can relate the parameters to get the value. For example, here, undrained strength of clays for normal consolidated clay, as I mentioned earlier, kalau you ambil NC clay, kita akan dapatkan nilai K dia adalah 0.25. Dia punya value ratio dia lah. So this correlation implies that the undrained strength Cu increases with depth. So Cu is the undrained strength, effective V naught is the overburden pressure, vertical pressure. So it provide useful estimates of the shear strength but it's not exact. So somehow kita boleh correlate juga menggunakan vein shear strength ataupun kita correlate dengan IP, influence stress. IP ni kalau dia relates dengan embankment, you kena pakai balik lah formula ni. Somehow in order to relate antara CU dan juga EU, you can choose this one. Why do I need to explain yang ni? Sebab as you remember, as I said in the early grade class lecture, bila kita nak buat analysis design mostly untuk geotechnical parameters, dia ada certain parameter input yang you have to choose very careful, yang mana you cannot simply choose this value. No, you need to consider a few factors. For example, history of the soil, and then the conditions of the soil, the strength of the soil, and then do you have any correlations parameters, just to give you a simple short idea the typical value. For example here EU yang modulus untuk undrained. Kat mana kita nak pakai dia punya application dia? Dekat settlement ataupun compatibility analysis, yang mana kita ada immediate settlement. For example, immediate settlement they can use dia ada formula kan, as immediate sama dengan apa formula dia, kat situ ada satu parameter kita kena tahu nilai EU. Okay, nilai EU ni kalau you nak buat eksperimen just to get the undrained yang modulus, it takes time. But somehow they can be correlate dengan menggunakan undrained shear strength. So ataupun kalau you tak ada nilai undrained shear strength, you ada nilai undrained yang modulus, you boleh juga dapatkan nilai SU kat sini. But remember, it is rough correlations. How to ensure that the result is correct or not? You kena buat validations lah, dapatkan daripada past results ataupun previous articles to just shows you are in the line of the findings. Maknanya jawapan yang you dapat tu betul kan? Okay, yang ni pun yang saya mention tadi lah, location and the kind of the clay present sama ada NCBCO ataupun overestimated ataupun underestimated of the strength. Okay, somehow yang ni pun SPT ni saya rasa benda yang common. Kalau kata you tak nak you nak dapatkan nilai SU daripada SPT pun boleh, CPT pun boleh. Cuma yang ni saya tak explain dengan lebih details lah. Okay, yang ni as I said lah, typical stress strain response bila awal-awal kelas tadi kan, yang mana kalau biasa kita akan dapat this line of curve antara stress dan juga strain. How this is shows you the effect of the pore water pressure. Okay, volumetric strain, kat mana dia sama ada nilai pore pressure dia increase ataupun decrease for these conditions of clay, normal ke ataupun over consolidated, semua tu you have to be careful in the right to explain, to describe the behavior of the soil itself. Okay, just now is on the clay. Yang ni kalau kata typical stress strain untuk sand pula, you conduct consolidated drain test. Okay, drain test tadi kalau you refresh balik our stress pass, ESP kita akan sama dengan total stress pass kan. Okay, yang ni adalah keadaan yang mana you can have a ratio between effective sigma 1 and effective sigma 3 by using this formula also. And how it is shows you the curve for each sample for different stress increment from one sample to another samples. So yang ni pun they give to you the effect of the volumetric strain bila ada the pore water pressure reading. Undrained clays. Okay, we break 5 minutes. We break 5 minutes before we start again. Okay, let's continue for remaining slides here. Okay. Okay, yang ni slide-slide terakhir lah. Tadi apa yang saya explain tu adalah general view what exactly stress pass dalam keadaan efektif ataupun total, sama ada triaxial, CU ataupun CD. How about untuk clays and sand? So dalam kes ni, when you talk about geotechnical engineering, our major group soils concern clays dan juga sands. So we want to see that macam mana the strength of these two major group of the soil. So kalau you go details, actually banyak lagi jenis-jenis soil in specific subgroup lah kan. Kita tak tengok lagi pit soil, kita tak tengok mixture antara sand dan juga clay. So what is exactly when you deal with the clays, for example here, in the situations stress at point A dan juga stress at the point B, you can see what we measure the undrained strength at point A and B at the rough field test, pinch CPT or depth test CU or CUU. So the undrained shear strength at point A dan juga point B, adakah dia lebih kurang sama? Ataupun bolehkah kita pakai nilai C dan juga nilai V untuk dua-dua conditions A dan juga B. You tengok sini pada point A, pada point B ni nilai stress je, logically if you relate dengan depth, of course dia berbeza lah. For example, when we look at vertically, stress pada point A lagi dekat from the ground surface, manakala point B ni lebih in depth lah, dia lebih ke dalam. How to relate these things antara A dan juga B? So we talk about stress at A dan juga B punya depth, and how about the effective P dan juga effective C. So when you plot this one, the simplest thing when you check on place dalam keadaan undrained, it's an easy way to determine in terms of, I mean that dia nilai strength lah kan. So ini yang biasa kita plot dulu. You akan dapat effective stress Mohr circle for undrained failure at stress point A dan juga pada point B. So bila you plot circle, the CU test otherwise associated with undrained strength. So the effective strength Mohr circle at failure corresponding to the different undrained strength at A and B are tangent to the C and V line. So it says that it will give you the same value of the V prime dan juga nilai C prime. Dalam kes ni C sama dengan kosong. Walaupun tadi kita tunjuk yang mana point A lebih dekat dengan ground surface dan point B lebih jauh ke dalam pada ground surface. Bila kita plot Mohr circle, rupanya nilai V dan juga nilai C dia sama. Nampak tak dia touch to the tangent line, touch to this circle A dan juga circle B, that give to you the failure line. Tapi bila kita nak cerita on part of the stress pass, so the Mohr circle grow as the soil at A and B undergo undrained shear until it mobilize the undrained strength of SUA dan juga SUB, undrained strength at A, undrained strength at B. Okay, yang ni yang kita nampak tadi kan, dia punya Mohr circle bila you plot failure line. Okay, tapi bila kita nak dapatkan dia punya stress pass, and then you relate to also dalam in sebutan kat sini kita nampak dia punya total stress dan juga effective stress, you akan ada satu conditions yang mana one here streak indicates to you the total stress pass, the other side here indicate to you the effective stress pass. So the difference between the dashed red line and the full red line, that is a delta U. Di sini kalau you dapat dia punya perbezaan tu adalah delta U. Similarly untuk sampel B. So bila sampel B, you akan dapat total stress untuk undrained failure at B dan juga effective stress untuk undrained failure at B. So nampak tak kat sini, one is the total, another one is the effective stress, but the conditions of the failure masih lagi dalam keadaan undrained. So yang mana kita boleh nampak kat sini, Bila you talk about failure line, dia akan bagi nilai C dan juga V yang sama. Tapi bila you look at closely on part of the stress pass, dia akan bagi you different thing. Okay, yang ni adalah benda yang sama juga. Cumanya dia keluarkan dalam stress pass. So they remove circles. This is what I said here. Yang ni daripada failure, daripada original effective circle ESP. Yang ni adalah total SP. So the difference between this dash and full is a delta U for point A dan juga delta UF at point B, and created to you the connections from the stress pass line for ESP B dan juga ESP for A, that is the KF line. Yang mana you akan dapat the angle of the KF line. So this one for clay. Kalau kata untuk sand, we want to see that is this the strength parameters will be same as what we seen from clay just now. Okay, dalam case ni, you akan nampak untuk keadaan total stress, yang ni dia buat dalam consolidated drain test. So bila consolidated drain test, dia akan bagi you in case of the, of course kalau tadi pun clay, the same image as what you have. Example here, effective curve kan, kita akan nampak dia punya sample A pada sample B pun benda yang sama. So how about this one? The effective or the total stress Morse curve at failure corresponding to the different drain strength at A and B also tangent to the C and V line. And what it says from the last for this part, untuk summary untuk case clay dan juga sand, you have to check that something that yang satu untuk clay dia adalah CU conditions. Tapi bila you cerita untuk sand for long term conditions, you can get the same as what clay has. Contohnya dari segi nilai, dari segi the curve of the Morse curve in terms of the effective, and then sample at point A, sample at point B, dia akan bagi nilai V dan juga nilai yang sama. And this time dia assume that the effective is equal to the total stress Morse curve for undrained at A dan juga for undrained at B. When you look at to this one, yang ni adalah drain shear strength long term. Kalau ikutkan memang dia akan pakai effective strength parameter. But the failure is occurred in the undrained conditions. So itu yang membezakan antara sampel pada point A dan juga sampel pada point B. Pada sampel point A ni, you akan nampak the failure occurring at the undrained. Meanwhile, pada sampel B, the sample fail in the drain conditions. Maknanya in terms of the long term stability, dia akan dapat the green curve. In terms of the short term stability in the undrained failure, this is the red curve. However, for the beginning, you can see that the effective is equal for both samples at A dan juga samples at B. So bila you nak transform balik dalam stress pass, the same concept yang mana you kena dapatkan dia punya TSP for both sample A dan juga for both sample B. So that's end for our afternoon lecture today. Any question? Soalan tak? Okay, don't forget to answer the questions. Some student I have seen did not participate in the learning activity as I mentioned earlier. Sebenarnya kita punya lecture ni adalah 3 jam, tapi saya try allocate actually 1 jam lebih lah sebenarnya kalau cantik, tapi sebabkan subject ni quite heavy and then need more explanations, so kita try sikit lah 1 jam lebih. Sometimes kita akan buat recorded video ataupun additional video from YouTube. For this moment, when I almost finished 2 hours for online class, the remaining class 1 hour will be on the learning activity as offline attending offline class lah. Maknanya dalam offline class tu untuk 1 jam tu is a tempo durations you need to check from your future apa aktiviti kena buat dan apa calculation yang terlibat, apa benda yang you perlu tahu. Again, the durations to complete the learning activity is around 7 days. Walaupun sebenarnya dalam timetable tu dia allocate only on the Monday daripada pukul 4 sehingga pukul 5. So use wisely time management untuk you complete the learning activity in the offline class. Ada soalan?
Madam, saya nak tanya sikit.
Okay.
Madam, untuk yang effect of sharing tu kan yang parameter B tu, so dia memang 1.0 ataupun dia parameter B tu dia ada formula dia sendiri, Madam?
Okay, B ni kalau you tanya power water pressure kan?
Yang apa tu? Yang effect of sharing yang saturated soil ni tu.
Okay, dia bila melibatkan power water pressure dia akan ada parameter A dan juga parameter B. Okay, parameter kalau kita tengok nota parameter B tu dia assume as a 1 kan? But this one depends on the soil tau. Kalau dia assume sebagai saturated, dia akan big, maknanya 1. Sharing dia B tu nilai 1. But somehow nilai tu boleh berkurangan jadi 0.96 bergantung kepada keadaan atau bergantung kepada sample type tu. So in back to the formula, there's no exact formula, but I think that they only can relate between the given U tadi tu yang saya tunjuk dalam slide sehingga formula asal dia untuk dapatkan B dan juga nak dapatkan nilai A. Tapi the variety of B tu berubahlah kepada keadaan jenis clay tu. Other than that, you can check from also a textbook. Let me check what page. Dalam textbook pun you boleh check kalau bawa chapter stress pass with low 167 itu kalau dia melibatkan consolidations lah. You boleh refer juga what are the commons B value during the consolidations, during unload dan juga during loading for the B and A value. Okay, I think that's the answer for this moment. I can give to you how to find the value for B in the pore water pressure ataupun dalam keadaan saturated clay. Boleh? Okay. Okay, dalam textbook ni kan sebenarnya dia stress pass ni dia banyak lagi formula yang dia boleh, dia bukan formula, dia banyak lagi teori yang kita boleh represent our stress pass. Antaranya kita boleh pakai Roscoe stress pass. Maknanya kita kena buat some sort of normalizing and equivalent stresses lah. Ataupun the simplest one here kita guna S dan T and also P dan juga Q. Untuk consolidations tu rasa you kena pergi juga ke textbook shear strength untuk tengok the effect of the pore water pressure in page number wait a second. Okay, 232 pun boleh kat situ ada. Sebab kat sini dia banyak main dengan critical state. Yang tu contohnya lah Roscoe failure tu is part of the critical state. Macam mana dia nak give the effect of the pore water pressure and the failure envelope over consolidated. These are the things that you have to look at closely. But again for your lesson plan ataupun untuk syllabus ni, kita tak pergi sampai critical state tau. Dia punya stress pass tu. Your stress pass hanya cover untuk ST dan juga Q and P plane. Maknanya for this formula contoh tadi M untuk dapatkan slope angle of the stress pass, you kena tengok kalau dia pergi ke state Q dan P plane, kita nak dapatkan dia punya slope angle kena guna that formula lah. But the detailings untuk stress pass in critical state tu you tak cover dalam syllabus. So you boleh pergi ataupun turn to page for example 247 sebab yang ni kan bila you tengok sepanjang explanation study saya explain dia cannot avoid daripada talking about the strength of the soil. Macam mana daripada one this experiment sama ada CU ke CD can give you the value of the strength. And then from the strength common graphical presentation dalam bentuk Morse ke, dia tukar pula ke dalam bentuk stress pass. Stress pass ni selalunya they can relate to the stress history of the kepada samples ataupun any site locations tersebut. So the other way is that selalunya bila kenapa tujuan kita buat dekat apa tujuan bila kita pergi ke site kan kita tak tahu contohnya existing site tu nilai tegasan dia tu berapa dia punya stress history tu macam mana, adakah site tersebut pernah mengalami overburden stress yang over consolidated contohnya clay itulah kan. How do we know that the sample ataupun clay at site has subjected to over consolidated etc. And the further investigation by conducting the triaxial test. So you boleh buat triaxial test melalui CD dan juga CU. From that you boleh kaitkan the stress pada site tadi tu dengan stress yang you dapat pada lab. So you can orang kata simulate lah the stress condition at site dengan stress condition at lab. Adakah dia represent the similar thing? Somehow macam sebabkan sand ataupun soil profile ni dia tak boleh dilihat dengan cara simple lah. Maknanya you pergi site, you pijak site, you dah tahu dah okay site ni jenis sand. No, it's not that way. Maknanya you kena buat some site exploration, buat standard penetration test, you ambil sampel sikit, buat dekat further determination ataupun investigation untuk tahu stress history. So similar thing happen here. Maknanya in terms of you nak dapat the exact strength of the soil at site tu dengan cara you buat experimental investigation. Experimental investigations tu nanti akan explain to you the strength of the soil at site melalui result triaxial test contohnya. Kalau kata you pergi dekat site tu you ambil sampel, sampel ni fully saturated kan. Maknanya nanti bila you nak buat testing, triaxial test tu, you kena buat testing yang berkaitan dengan CD contohnya, CU. So you dah tak boleh buat simply testing UU lah kan. Sebab UU ni is very simple and short testing untuk dapatkan nilai C dan juga V. In terms of reliability, strength value, dia kurang berbanding you buat CD dengan CU sebab kita ada the effect of the effective stress dengan total stress, kemudian kita ada the effect of water pressure. That's why on the initial slide yang saya present to you adalah stress soil mass dalam keadaan fully saturated. So when the soil involved with very problematic high water contents, so the easier way to find the right strength of the soil dengan cara buat triaxial testing lah. Kat situ you boleh buat water pressure. Okay, ada tak soalan? Sorry saya tak jumpa page exact number lah untuk represent to you the consolidations, the pore water pressure. Tapi yang tu memang banyak dekat critical pass and stress pass untuk cerita pada awak the rest the details about parameter B and U bila you dealing with the pore water pressure effect. Ada soalan lain? So nanti you go straight to the U future, you tengok learning activities and go back to the U future also for having the extra activity, additional activity untuk you buat during your free time. Okay, I'll see you in the next class. Thank you. Assalamualaikum.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.